Welcome students. This video is on the effects of changing a and c in ax squared plus c. So this is similar to the quadratic equation that we learned last time, which is ax squared plus bx plus c, except we're getting rid of the middle term and we're just focusing on the first and the last term and how that affects the parabolas that we learned about. We learned that a quadratic makes a graph that looks like this, or even sometimes like this. And we're going to learn today's lesson what happens when we change the number for A and what happens when we change the number for C. Alright, so changing A, we can make A a positive number, or we can make A a negative number. If we make A a positive number, our parabola faces up like that. If we make A a negative number, our parabola faces down like this. Okay? If you think of it, a positive person is always smiling, and a negative person is always frowning. And this will help you remember that if it's positive, we're smiling. If it's negative, we're frowning. The other changes that you can make to A have to do with the size of the number. This is a lot like slope, where slope, if we made the slope bigger, it made the line go up faster, and we made the slope smaller, like a fraction, it made it flatter. Well, we're going to look at it in the same regards this time. Okay? If we make A bigger, and when we say bigger, we're talking bigger than 1, then this creates a thinner parabola. Okay? So if this is a normal parabola with 1x squared, if we change it to 5x squared, that's going to make a much thinner parabola. And we're going to take a look at this on the calculator, but this number going from 1 up to 5 makes it a thinner parabola. Okay. If we make it a smaller number, so smaller than 1, which is typically a proper or normal fraction. So if 1x squared is our normal parabola like this, then what would happen for 1/4 x squared? And it's the opposite. If bigger numbers made it thinner, then smaller numbers make it wider. So if 1x squared looks like this one, then 1/4 x squared is going to be a much wider shaped U. And like I said earlier, we're going to look at all of this on the calculator during our class when we study this. Alright, the last thing that we're going to talk about is changing C. Okay? C is the number that's added or subtracted on the end of it. For example, y equals 4x squared plus 2. This plus 2 is your C. And this has to do with shifting up or down. And it's very similar to y equals mx plus b. It's very similar to what the b did. The b moved the line up and down along the y-axis. The c is going to do that very same thing. So if y equals x squared plus 0 is the normal or parent quadratic, it sets down here at 0. If I do y equals x squared plus 3, this shifts it up 3 units. So instead of setting here at 0, it's going to set up 1, 2, 3. It's going to set up here like this. It's still going to be the same width because it's still 1x squared, but it's going to shift up. Okay. If I change it to y equals x squared minus 4, this minus 4 tells you we're going to shift the whole quadratic or the whole parabola down 4 units. So the normal one would set here at the origin. This one's going to set down 1, 2, 3, 4. It's still facing up because of this number. Okay. Now, one of the things that can happen is we could do a multiple things to the so it's just like I told you guys when we were studying about mx plus b. I could look and predict what's going to happen. Like somebody could give me y equals 2/3 x plus 3, and I know that this is going to be flat because that's not a very big slope, and this is going to be shifted up 3 without even graphing. I can do the same thing to a parabola. Y equals 4x squared minus 3. This means it's going to be super thin. Okay? This is thinner than normal, and this is shifted down 3 units. Okay? If you give me something like this, y equals negative 2/3 x squared plus 5, this negative tells me that it's going to be frowny upside down because it's negative. This tells me that it's going to be wider than normal. And this tells me that it's going to shift up 5 units. So on a graph, it might look something like this. It's going to go up 5 units, 1, 2, 3, 4, 5. It's going to be going downhill or downward, and it's going to be really wide like that. Okay? Make sure you remember to take these notes on your own paper, and I'll see you in class.